Good. Hello, everyone. Thanks for coming to listen to us talk about the internet computer. I'm Dominic Williams, founder and chief scientist of the DFINITY Foundation, which is the primary developer of the internet computer. And we're going to talk about the internet computer today with a particular focus on how it can be used in the Ethereum ecosystem. So the DFINITY project actually came out of the early Ethereum community in 2015 with a view to pursuing a vision of a world computer that ran at scale, such that you could build absolutely anything on it. And the project took a long time to get into production just because of the complexity that was involved. And you may have heard, DFINITY has a large team of cryptographers, computer science researchers, engineers, and so on. And we got into this not just because of the world computer vision, but because of a sort of general appreciation of the way that tech history arcs from private infrastructure towards open networks. And back in the 1990s, we saw this. The internet was emerging, and people were proposing alternatives. Microsoft and Oracle began pushing this idea of the information superhighway, which would be a kind of walled garden network where the content would be curated by these big corporations. And in the end, we got the internet, which is formed by privately owned and operated routing devices that are combined by the TCP/IP protocols into one open global network. And today we have traditional IT, which is where most people build. And that's cloud services, databases, web servers, middleware, CDNs, firewalls, all of that stuff. And we think eventually people are going to move on to the open network. And the internet computer is formed by privately operated and owned node machines that are connected by the ICP protocols to form a serverless, autonomous cloud. And there are these two things, the internet computer network and something called internet identity. And they enable two other things that we're very interested in. One is open internet services. An open internet service is a service which is fully autonomous, runs under the control of something called a service nervous system, which is an evolution of DAO technology. And the other is what we refer to as a sovereign enterprise, where the infrastructure is tamper-proof, doesn't need to be protected by firewalls, and doesn't have any hidden backdoors or kill switches, which of course, if you build with closed source software and cloud services, are present. So how does this help the Ethereum community and the Ethereum ecosystem? So the internet computer can help address the final frontier of Ethereum decentralization. So today, when you have something like a metaverse, in practice, that runs on centralized traditional IT. Like all of the compute, all of the data, in vast majority, is probably on Amazon Web Services, and the service is really running on, databases, using a web server, memcache to speed it up. And that's where all the hackers head. That's where the problems typically go. Obviously, it's not censorship resistant. You have to trust the developers. Those guys have a backdoor. They can log in with their username and password and arbitrarily modify code and data and things like that. And we want the ecosystem to progress in this direction and replace traditional IT with autonomous internet computer canister software. And for that canister software to be placed under the control of a service nervous system, which is a kind of evolution of DAO technology. So end-to-end, the whole thing's secure and decentralized, and of course, autonomous. So just quickly, how does the internet computer work? I mentioned that you have these independently owned and operated node machines, and they're run by people we call node providers from data centers around the world. So this thing isn't based on cloud instances, it's based on physical hardware, a bit like Bitcoin uses like ASICs for hashing. And actually the moniker applied to the network model is proof of useful work. So the Internet Computer Protocol, ICP, combines these nodes to form efficient subnet blockchains. And each of these additional subnet blockchains adds more capacity for running canister smart contracts. And we'll come back to those in a second. And then these subnets are combined into one serverless cloud environment. I mean, more specifically, serverless autonomous cloud environment. And that actually has unbounded capacity. The network can just increase the capacity by adding new subnet blockchains ad infinitum. And that's what the internet computer is. So it's really a new form of blockchain. 2009, we saw digital gold emerge, Bitcoin. 2015, we got smart contracts with Ethereum. And when the internet computer launched, it provided something completely new, autonomous cloud. And the internet computer has some very interesting technical capabilities. And one of these is multi-chain, native multi-chain capabilities. And this derives from something called chain key cryptography. And it allows the internet computer to interact with other chains without there being bridges, just using trustless cryptography. And this is one of the key ways we think that the original Ethereum World Computer Vision from 2014 can be realized. So what's cool is that canisters on the internet computer can sign transactions on other blockchains. And of course, canisters aren't doing any clever cryptography themselves. They're just interacting with APIs that the internet computer environment provides them with. And they can create, for example, ECDSA public keys and then sign messages using the virtual private key. But there isn't a private key. The signing's done by the internet computer itself using this thing called chain key cryptography. And full network level integration with Ethereum's coming. You can still sign Ethereum transactions at the moment, but you have to forward them via the user experience. One network level integration is fully working today, and it produces something called chain key Bitcoin. It's a kind of Bitcoin twin that can be processed by canisters, and very, very cheaply, has a finality about 1 second. Enables you to use Bitcoin in things like DeFi, social media, and so on. Bidirectional ICP ETH is coming soon. It's quite challenging to implement at the network level for a bunch of reasons related to gas and so on. But it's coming, and it's going to enable canister smart contracts on the internet computer to directly call into Ethereum smart contracts and vice versa. So obviously at a very basic level, you could bring ERC20 tokens onto the internet computer, where you process them in an order book exchange. But you can do much more sophisticated things than that too. So, canister code, what is it? Firstly, we have a sort of general vision again, which is that just in the same way the software is eating the world, like everything's going to run on software, smart contracts are going to eat software. And that means eventually there'll be a world computer, and everything will be coded using smart contracts. And of course, when you code with smart contracts, you don't need a database, right? I mean, the data is stored inside the smart contract. That's one of the interesting properties of smart contracts and the differences between smart contracts and traditional software. the data is actually stored inside the contract itself rather than in an external database. And if you can scale that up, you don't need databases anymore. Don't need firewalls, of course, because they're tamper-proof. So rewinding to 2015, what was introduced with smart contract software? Well, it's actually a new form of software. And they have all of these amazing, smart contracts have all these amazing properties. So they're tamper-proof. Systems running on Ethereum aren't surrounded or protected by firewalls. They don't need it. They're unstoppable, of course. They're autonomous, which means you can create software that exists independently of a person or organization. Smart contracts can process tokens. They're very easily composable in ways that enable kind of dynamic collaboration between independent parties. And of course, they're borderless. No one even... Where does a smart contract live exactly? It doesn't live anywhere. It just lives in cyberspace, or cypherspace, depending on your definition. Canisters are a new form of smart contracts, and they aim to sort of generalize what we had back in 2015. So they're fast. They sort of run at web speed rather than blockchain speed. They can scale. We aim to make scaling on the internet computer easier than it is on using traditional IT. It's multi-chain, natively multi-chain. It's highly efficient. It's important for things like the carbon footprint, but also cost. Compute costs on the internet computer are approaching traditional IT, and they can process HTTP. And that's, of course, essential if you want to create a decentralized user experience. And they enable a sort of pure form of Web3. Here we have the internet computer, obviously a very big approximation with the screens showing something called OpenChat. It's a service built on the internet computer. Actually, OpenChat is composed of many thousands of canisters, so there's something to bear in mind. But the user is interacting via the web browser with these services over HTTP, and there's no traditional IT involved. Internet identity, which I mentioned earlier, is creating RPC transaction sessions. So there's no wallet involved. You're not like signing every individual transaction and authorizing it with your Ledger wallet. Instead, what's happening is that you log in, if that's the right word, you create a session using this thing called internet identity. And you, of course, have a key that's used to create your session. But the internet computer, this is one of the really interesting aspects of it. The internet computer itself has a single master 48-byte chain key, right? So if you know this single 48-byte chain key, you can you can verify the correctness of every single one of your interactions with the network, no matter how big it gets. And of course, a chain key is an assembly of a bunch of things like, hash paths and threshold BLS signatures and so on. But all you need to know is this 48-byte chain key, and you can verify your interactions with the internet computer. And if your interactions verify, you know the actual chain's running correctly too. Last thing, I mentioned this thing, the service nervous system, the whole network, the whole internet computer runs under the control of this thing called the network nervous system. Same kind of evolution of DAO technology. And it's a factory for service nervous systems. And if you have canisters that need to be updated, of course you can make canister code autonomous just by setting its controller to null, right? Then nobody can update it ever again. But if it's a complex system, you're going to need to upgrade it and fix things. So if you want to make that autonomous, you assign it to a service nervous system. Internet identity does a bunch of things. It's actually created by a combination of these three technologies. TPMs, it's got a trusted platform module. It's a chip that's inside modern devices like a phone and a laptop. And that holds keys, and it can use those keys to sign messages inside the chip, and you can't break the chip open to get the key out. A protocol called WebAuthn, which connects code inside the web browser to those TPM chips, and of course, a bunch of cryptography on the internet computer. So this is what it looks like. You go to the OpenChat URL, for example, oc.app, click Launch App, choose your internet identity, authorize, it could be whatever you want, right? Fingerprint sensor, Face ID. That's activating the TPM, so the session's being sent inside the TPM where your key is signing it. You have multiple devices attached to your internet identity. And boom, you're in. So it's a different way of authenticating yourself to a Web3 service. It's very easy, it's secure, your key can't be stolen. There are various ways you can stop yourself losing the key, but for example, by adding multiple devices to your internet identity, or if you want, adding a recovery key with a seed phrase. So, when you combine all of these different pieces, you can create these, end-to-end decentralized, autonomous Web3 services that are more powerful. So OpenChat, which I just mentioned, runs 100% on the network. Chat accounts are also wallets, so it's kind of full SocialFi. You can send Satoshis with a message. There's no wallet or anything involved. Under the skin, of course, every message is a blockchain transaction, and the thing is stored as part of the blockchain state. And this was actually the first open internet service. It kind of went live in April, and it's fully controlled by Service Nervous System DAO, which means any updates to OpenChat are proposed to this Service Nervous System DAO, and then it applies them if they go through. Hot or Not is another one that recently transitioned to becoming an open internet service running under the control of a Service Nervous System. It's like a fully tokenized TikTok delivered into the browser. And it's creating like a sort of ingenious decentralized economy. So users bet, it's not actually hot tokens, but we'll go with that for the second, for now. Users bet hot tokens on whether videos will go viral. Users help with content moderation. And then the creators of viral videos get rewarded by these tokens, and eventually advertisers are going to have to pay with these tokens in order to get their ads onto the service. And so that's what drives the value of the tokens and creates the economy. And it's designed to be a service that founderizes its users, like makes its users part of the team and creates this sort of virtual industrious workforce from the users. And that's what we think is the future of Web3. Again, the whole thing's controlled by an SNS. Final example is a thing called ICDEX. This is an alpha, it's not an open internet service yet. But it runs entirely on the internet computer. It's a full order book exchange created by a smart contract, right? And obviously it's hack-proof and transparent. Soon it'll be autonomous. And so, it provides an alternative to the centralized world where you have something like FTX, and there can be a secret backdoor created by someone like Sam Bankman-Fried, which gives them a $63 billion cheat code, et cetera, and allows them to sort of suck all the money out. This, we think, is the future. Continuous double auction exchanges, order book exchanges created by smart contracts, where even the user experience is created by a smart contract, where there's absolutely no backdoor whatsoever, and all of the updates to the exchange pass through the service, are proposed to the Service Nervous System and then applied. So considering all of these examples we've just been through, some things we should know. They're very cool, very sophisticated, got complex functionality, and yet they were built by tiny tech teams. The first two, I think, have core teams of 3 developers each. The exchange is a bit larger, there's like 10 plus, but nonetheless, these teams are small. There's no cloud, no database servers. They're running exclusively on the internet computer. You can do video streaming from the internet computer. Actually, I think Hot or Not may not be at the moment, but it's coming. And no firewalls, right? I mean, if you think about OpenChat, it's this very complicated messaging service where chat accounts are actually crypto wallets, and you can send crypto chat messages, and yet you don't need firewalls, and you don't need a security team. So I think that just speaks to how revolutionary smart contracts are as a new form of software. Something that's coming on the internet computer is the localization of subnets. Currently, subnets combine node machines from all over the world. So, the rule is, node machines from different node providers, in different data centers, in different geographies, and different jurisdictions, which is what we call deterministic decentralization, which is used to minimize the replication involved and to keep the cost very low. Localized subnets will combine node machines that are in the same geographical locality. And the question here is, going forward when we're looking at things like, fundamental compute infrastructure that runs the foundations of society and identity and things like that, should we be depending on US corporations? For example, should next generation identity turn out to be something like Visa or MasterCard? And we say no, and that sovereign societies cannot depend upon digital foundations in which other states might have kill switches and backdoors. And that's what you get when you use cloud computing services, closed source software, single sign-on services, even security hardware. So security hardware is proven time and time again to actually come with Trojans and backdoors and things like that. So I mentioned how you're going to get bidirectional calling from canister smart contract code into Ethereum smart contracts and vice versa. That means that all of these capabilities can be leveraged, or at least shortly it'll be possible to leverage them very easily from Ethereum. So you could build a user experience on the internet computer and have DeFi rails on Ethereum. In addition, one of the other cool features is something called HTTPS outcalls. The internet computer canister smart contracts can make outcalls that go through consensus, and the results are normalized. So you can pull things like price feeds into a canister smart contract from someone like Coinbase, or even from a variety of exchanges. And that enables you to create Web 2 integrations and sovereign Oracle functionality without relying on a centralized Oracle company. Lastly, but not least, internet computers are going to surely sort of add support for something called AI compute units with a pathway to full AI smart contracts. So AI is going to be absolutely fundamental to Web3, and nobody should underestimate how important it's going to be to the future of society. And in the future, AI is going to want to, people are going to want to have AI analyzing all of their data. If you think about something like a metaverse, very likely a lot of the environment will actually be generated by AI, which will be fantastic. And AI isn't just about stable diffusion and large language models. It can even do things like compress data. And what's important is that all of this functionality is accessible from Web3. So in the future, it'll be possible from within an Ethereum smart contract to make a call into an internet computer AI compute unit, spin up a model, even direct it towards some training data, give it a prompt, get a response, process it, do whatever. Full AI smart contracts, further off, but working with people who are doing something called integral neural networks, and you can apply transforms to AI models to make them deterministic. That's how it's done if you're curious. And they'll be very useful for things like medical large language models, where you need to know with absolute certainty what the software is, what the parameters are, what the training data is, and the users need to know if they supply a particular prompt. They need to know with absolute certainty that an inference was performed and produced a specific response. So our mission is to essentially get as much of humanity's services and systems and services onto world computer. The internet, you don't hear much about the internet computer within the industry, but the compute on the network is growing. So currently it's performing about 250,000 ETH equivalent transactions a second when you actually look at the number of instructions that are being run. So it's growing, it's doing well. And I hope anyone here is interested. I'll be around for a while. Takes a look at the internet computer and sort of joins us in pushing in the next phase of decentralization. Yeah, thank you.
Was your button? Thanks.